Good morning, everyone. If you can please have seat to start. Can you listen to me with the microphone? Very soft. Ah, hello, hello. But we have just this one.
Is it working now?
Hello.
Yeah.
Now?
Loud enough.
Probando, probando. Okay. Good morning, everyone, and welcome to the JKMRC Friday Seminar Series 2026. On behalf of the University of Queensland and the Sustainable Minerals Institute, we would like to acknowledge the traditional owners and custodians of the lands on which we meet today. We pay our respect to their ancestors and their descendants who continue cultural and spiritual connection with country. And we recognize their value, contribution to Australian and global society. So it's my great pleasure to welcome Professor Mohsen. Professor Mohsen is director of the JKMRC, or Julius Kristnit Mineral Research Center at the University of Queensland. He's also program leader for future autonomous system and technologies within the SMI Center. His research focused on advanced process controls of sensors, dynamic modeling, and next-generation decision support system for complex mineral processing operation. He led multiple industry-wide initiatives to integrate AI and automation into mining in practical and scalable ways. His current work explores communicative process automation, or CPA, a new architectural approach to structuring and scaling decision-making in autonomous mining systems. So today, please, his talk will be about the hidden operation, why autonomous mining systems struggle with decision-making. So please join and welcome Mohsen.
Thank you. Good morning, everybody. Thank you very much for the nice introduction and for organizing it. And thanks for everybody joining, people that they are in person. And I know many people actually join online as well. Thank you very much. So it's my pleasure today to talk about this topic, which is, I think it's an interesting topic for discussion as well. So as we have been talking with Randall. So let me just go with the technology to work first. Yeah. So also, I would like to acknowledge the traditional owners of the land in which we meet and pay our respect to their ancestors and their descendants who continue their cultural and spiritual connection to the country and recognize their valuable contribution to Australia and global society. I have one more special acknowledgement as well that I would like to make, which is acknowledgement of our visionary founder of JKMRC, late emeritus Professor Alvin Lynch. And I essentially deliberately wanted to have his wife as well, because I know from feedback that I got from all of the alumni that his wife also has a big role in JKMRC. So I think when Alvin established JK in early 1970s, so his vision was actually a future that computers, computer programming computers would enable advanced automation and control of mineral processing plants. So that actually was the vision for the center. And more than 50 years on, so the vision still continues within our centers. And we are essentially frontiering that automation and decision-making in the process. And I think today is my pleasure to present some of the new thinking that we are developing in JKMRC and how we are working toward that direction as well. But I think all of that is, it's attributed to this great person who had the vision to start and establish such a center that actually is carrying on with the legacy. And I thought actually it's important to acknowledge his contribution. So when it comes to the decision-making in autonomous systems, the question is when their objectives are conflicting, when we have to decide between throughput versus recovery, when we want to say production versus maintenance, how much of those decisions are actually really made autonomously? That's a key question that always comes up. And I suspect that actually not much of that. So most of our operation actually, when they have all of these advanced systems, the decision really, the automation really stops when the real decision needs to be made. We have APCs, advanced process control. We got model predictive controls. We have all of these sensors and high historian systems. The AI now is coming to the system as well. But realistically, when we go to discuss trade-offs, how is done? Is it really done autonomously? How many of those critical decisions actually is made autonomously? In what I see, at least at the processing side and fairly across the other part of the process, that's generally done through negotiation that human operators make, isn't it? So when you look at the operation, you have a visible operation, a physical process. And usually you measure things and optimize them with the help of automation systems. So you target throughput, you get to capacity, cost, recovery, maintenance, fuel consumption, tons hold, and all of that. But there is a hidden side as well, if you think about it. And most of those decisions that is done through human interaction, it's the backbone of that hidden operation. So the trade-offs between essentially those competing objectives. When you think about different departments negotiating what should be done, what should be my target, how much tonnage do I need to haul from the mine, what would be the capacity in the crusher, how much I need to set my gaps in the crusher to feed the material to the plant. When it comes to uncertainties, so when we don't have enough data or the data is missing or certain information is incomplete, and who decides a decision is good enough? Most of that actually is done in that hidden side of the operation, is handled by human, and automation stops there. It's not going that way. When you look at the architecture of automation, it's genuinely designed for the process, but not for decision making. So when you look at the structure, you have IT and OT sitting in either side. So you have APC and MPCs and your Internet of Things and digitization in one side, and then the organizational-wide structures that collects data, standardize everything, and you use that to make decisions. But when you look at the human coordinators at the top, when it's in the stability of the equipment and the decision-making in the operation, that's pretty much fairly autonomous. But when it comes to those conflicting objectives, meetings, shift handovers, reports, phone calls, those are the things that actually makes the decision in those space. And they're genuinely outside the system. They are not part of the system. So when you look at it as a structure, it seems that actually we have a void in between our IT and our OT. So in one side, we have a very good plant-wide structure, digitize all the information, collect all of them, standardize them, and put it into the planning, reporting, and all of that space. In operational side, we got all of these advanced technologies, SCADA, PID controllers, APC controllers, MPC controllers. I mean, there are some realities that actually might not be much in our favor as well, in terms of you have operations that they have to carry for 20 years or more, and there are legacy systems that we have to deal with them as well. And the general mentality is don't touch it if it works as well. That's fine, but still you design them to start influencing the information, using the information and influence the operation to optimize. But when it comes to the trade-off management, there seems to be no system that actually does that part. That's a missing layer in our systems. So we have a very robust control overall. And even in the business system, we have very robust control. But that essentially, it lacks a very formal system that actually manages the operational decision-making in a complex situation. That's the gap. So when you look at the industry, already we are working toward that. So I know that people in the room and people online, there are groups that actually they're specifically working in that space. I just put two examples from the companies that I have been interacting with them, ABB and Honeywell. So they use AI or even plant-wide optimizers with the help of models or AI systems. And the idea essentially is to use them to understand overall structure of the plant and the process and make decision based on that. So these are two structures that actually, one is mainly around model-driven and the other one is AI-driven. So the idea is to use them. But when you look at those structure, you see the word optimization. All of the target is around optimization. So the objective is actually we try to use AI or models to predict behavior of the system, understand and predict the behavior of the system, and use it for optimization. So these are valuable. And the other approach actually is use the past behavior of the system, predict the trajectory of the system, and try to force our optimization toward that trajectory as well. So this is again a concept that ABB was presented in terms of we can use the past trajectory to find the reference trajectory that we want for the future, and then try to optimize our control toward that. So again, the underlying assumption there is the system already knows the optimal solution and the correct objective. But when you get the reality, that's not true. We always negotiate the objectives of the plant. We change essentially the directions. And those are negotiated. They are not optimized in a sense. So you have that hidden operation that actually through negotiation and discussion between our human operators and the system decides what should be the target now in the face of all of the constraints, uncertainty, changes that is happening. And that essentially wipes out most of the work that we have done upfront to predict the trajectory of the system because that keeps changing as well. So in reality, objectives often change, and the human is the person, essentially the group that makes the decision for what should be those objectives and how we should achieve them. So how about the AI solution? So I think all of you guys now heard a lot about AI, and now the buzzword is agentic AI. So everyone talks about that as well. Again, the current vision, and this is one of the structure that I borrowed from one of the essentially vendors that they offer this one. They call it operation-wide AI expert. And the premise there is you have these specialized AI agent that they are data-driven AI agent that they come in from different parts, and they have been very comprehensive. So they included HR, they included maintenance, they included marketing and all of them. And the idea is you got all of these AI experts that they are having the understanding of the system, and then they interact with the super AI agent that is essentially operation expert. And that essentially guides them to make the decision. So that's a current vision in terms of you train some of the AI and with the operational and organizational data, and that becomes a domain expert. And that coordinates the optimization. So again, this approach, when you look at it underneath, assumes that the optimal decision can emerge from the data-driven optimization. So it means that if I get the data and use that to optimize each of those subdivisions, I'm going to have a whole optimized process as well. But optimization alone is not enough for us. So when you look at the optimization, you need to be able to clearly define the objective of the process. You need a stable condition as well. When the variability happens, it's not very easy to achieve those objectives. The models that you want to use, whether it's for optimization or whether for prediction of those objectives, has to be reliable as well. And in this room, we have lots of model developers, many of the great ones. And I think all of them would agree that models are not always perfect. And you need to be able to predict the system behavior as well, and it has to be predictable. Who can say the ore that we are feeding to the plant is predictable? Who can say my pump is going to perform predictably? The wear, the maintenance issues, the ups and downs, all of that. And if there are trade-offs that needs to be resolved, unless you can quantify them, it's very hard to optimize them. And many of the trade-offs are not really easily quantifiable. At the end, you have to start doing a bit of a negotiation up and down, and then you finally come to a decision. In the real operation, first of all, you have to constantly fight with multiple objectives. One wants to push tonnage. The other one wants to minimize the cost. The other one needs the recovery. The finance one needs metal production. So all of those are genuinely competing objectives. When you want to optimize one, actually it comes at the cost of the other one. So the constraints and the disturbances keeps changing as well. When equipment fails, you're suddenly operating in a different condition. So it's a different constraint now. When the incident happened in a mine, now you're operating in a different operation regime now. If you hit a high pit ore now, your flotation is running in a different flotation regime now. So all of those constants keep changing. And the cross-functional decision-making is almost impossible for us, but we need to do that. A decision between blasting, between load and haul, between our crushing plant, between our flotation. And the priorities of the operations keep changing as well, and we know that for a fact. So when you come to the operational decision, it's not as easy as I will define the objective, stabilize the process, and move toward optimization. In most cases, you need to interpret the situation, make a judgment call, and negotiate some of those options. It's not only for one unit to make the decision. It has to be negotiated with some of the other groups as well. So what's the fundamental thinking in that approach? That's essentially our current industry approach. And I think when you look at it, the traditional automation essentially assumes a system are predictable, they are measurable, and they are optimizable. That's a fundamental assumption in our automation systems. And they heavily rely on system thinking approach. So essentially, what you do is you break the system into subsystems. That's a reductionism. And then you try to control each of the system to the best optimum that you can. And then when you hit a bottleneck, you start finding where is the bottleneck, how can I de-bottleneck it, which goes through the whole sequence again. Break the system to subsystem, optimize it, hit the bottleneck, go back again and do the same thing. And when you think about implementation of the AI into that system as well, which is what people are pushing at the moment, and many operations, they're excited about the opportunity AI brings into automation, there's no difference as well. So essentially, the intelligent cannot make decisions without a real truth information from the process at that time. And we know uncertainty that exists with our data, missing information, and all of the context that is missing from the information that you collect. So the sensor data is not enough to understand your context that you're operating with. All of the information that exists in negotiation between maintenance people and operators, that this pump is not very good, you have to treat it a bit nicely, or you cannot just push this crusher at higher speed because the belt actually now is worn out, it's at the final age of it. So, and we don't have it in our essentially warehouse, so you have to carry it for the end of the week when it comes. Those are not captured in the data. And the wrong thing that I can see now in some of the cases that I'm really advocating against it as well is there are many attempts now that people talk about light of control rooms, taking to remove human out of the system. And we see human is the problem. If we take it out, the AI can do the problem without human intervention very good. That's actually a wrong thing to do as well, because there is no way for AI to get the context in many cases, and we need those. But that's essentially in the wrong direction as well. So this might bore you again, because I couldn't stop myself to put this on as an academic. But for me, it's important for us to understand. And if you don't go that level deep, you wouldn't know why this type of system is designed that form. So essentially, the automation, as I said, it has a long history in system theories. That's the crux of what automation system works on. And the main thing in there is your system is regulated, so you can actually regulate your system, and you know, or you can preset the objectives as well. That's the fundamental path in system thinking. So, and that's how, if you look at the automation system is designed. So you know where the system should go, and you know that by advanced automation, I can regulate it. And then you say, okay, I'm going to regulate the system and achieve the target that I want. That's what they need to do. But the real plant actually is somewhere there. We are not always sure that's the correct objective. As I said, all of the trade-offs, the changes that happens, and the decision that humans make through negotiation actually changes those objectives. The objectives in reality are variable. You have to keep adapting that depending on the situation. And the system is not always regulated. It can be variable as well. Emergence happens and the behavior of the system changes. So you have to be prepared to adjust to that change in the behavior as well. So that's the reality of the operation. So the question is, what if automation actually could negotiate decisions as opposed to, I'm going to dictate the optimum situation? So essentially, an automation system that instead of dictating the optimization, negotiate the operational decisions in terms, and that in the presence of the uncertainties. So to be aware of the data that are missing, to be aware of the data that they are poor quality. If you think about the human operator doesn't stop the plant because the sensor is off. It doesn't stop this controlling the plant because a sensor is off calibrated. They make the decision in the face of all of those uncertainties, in the face of all of those constraints. What if we can design a system can do that as well? And also understand and make the decision in the face of conflicting objectives. And when the information are not complete, because we are not always having all of the information as well, but still we need to make the decision, and a human makes that decision. But what about the system? Can we design such a system? And I think my answer is yes, we can. So the communicative process automation, which I call it essentially, is one of those approaches that if you fundamentally rethink about the automation and say the automation is not always here for optimization, although that's one of the tasks, but also automation should be able to negotiate decisions as well, then one of the techniques could be what we are proposing as communicative process automation. So the idea essentially is you have a hybrid approach. Instead of just going with the system thinking, you incorporate complex system thinking as part of the process. When it comes to the unit level, because the problem is more constrained and smaller, we can rely on our current existing automation paradigm in terms of let's get the objective and try to optimize the process toward that objective. But when they go to the process-wide, because the complexity start increasing, and that's where in between groups and negotiation needs to be happening, then the system complex thinking can come in, and the negotiation layer can come in and negotiate those objectives and targets, and then get help from that traditional automation system to push the system toward that new target that we have as well. But what happens is you genuinely accept that there are emergencies that might happen that you're not aware of them, and it could happen. You accept that you can adapt to unknowns when they become known, and you negotiate and communicate actions. So this is where actually AI can help with effective decision-making as well. So this is genuinely a different way of utilizing AI in that space. So what we want to do is we want to automate and scale that decision-making that human operators usually make and help to essentially embed that as part of our autonomous decision-making. So instead of forcing the system to keep chasing optimum that is dictated by IT and OT, that layer essentially scales the level of negotiation and decision-making that human makes, and in a structured way, and dictates where should be the potential optimum now. And then you go from that. So maybe, this one I use term adaptive control, but generally it's a different in terms of what adaptive control currently in industry is. When you talk about adaptive control in current industry, you see a fixed trajectory, and you just choose where in that trajectory you're going to be. That's the definition of the adaptive. But the adaptive in here actually is that trajectory can change as well. So it's not fixed, it can change. So the agentic AI that we have, so I'm using the same jargons that people that use in industry as well now, it's based on the context and the trade-off. It's not fixed based on known targets. So their skill set, which I'll show you in a moment, is different. They are not domain experts in that process. They're experts in negotiation and making decisions in the face of uncertainty. So this is actually an additional layer. So it's not replacement for the existing system. It has to come on the top because, as I said, it's a hybrid approach. It's not either of those. And decision will include the system limits, include the constraints. It respects the emergence that happens and adapting performance targets as well. So this is one proposed structure that we are working at the moment in JKMRC. This is a CPA moderator agent. Essentially uses the number of agents that they are specialized in negotiation and decision making. So those agents are agnostic to the process. They are not process experts. They are experts in how you would negotiate in case of uncertainty, in face of competing objectives, in face of disputes, okay? And they have different roles to play that they are specialized into that. They connect to the system through that interaction hub. The beauty of this system is actually you don't need to feed tons of data to them to train because their skill set is different. It's not in the process. It's in that negotiation domain. And I will show you how we use some of the backbone essentially that exists in the science to train them. Then all they need is access to the process to understand the reality of the process, get the data that they need, incorporate human perspective and the knowledge as part of that negotiation. So essentially, we can't remove human out of the equation, but what we want to do is we want human to be part of the equation, but it's not the sole decision maker. We want to make the decision making a structured process based on some framework that essentially make it consistent, but human perspective is part of that equation and decision making. And then the system actually doesn't learn from the process. The knowledge and the learning that is generated, it is stored in the knowledge center. And that's, again, another key point. Some of the concerns that many people they have is, oh, you're training your agent with my data, so what's happening? No, actually, those agents are not trained with your data. The agents are specialized in decision making. They trained with some concept and information that is not dependent on the process. And the knowledge that they generate, it's shared in that knowledge center. So if I completely take this one and put a new AI moderator there, because that knowledge exists there, they can actually perform the same way because the knowledge is captured there. All of the decisions that has been made in the past, the actions and the results, all of them there. So that's essentially the whole process. How it's going to work in reality. So if I put this system at the face of grinding and classification and flotation, okay, so I'm making a process example because we are mineral processing people, but I know you can put it in the mining space as well. So you need to discuss the trade-off between your grinding, your recovery, and your classification when your ore suddenly gets harder or you get high peat content now. So that's where the emergence and the risk monitor start identifying anomalies in your data. And that triggers a negotiation because that shows that the system now, it's not what it used to be. The emergent happened and the system behavior has changed. So that triggers a negotiation. And then the discourse agent and the micro power dynamic agent, they start identifying who are the stakeholders in that discussion. We have grinding, we have classification, we have flotation, and we have operators in each of those fields. They provide the context and the reality. And the micro power dynamic agent essentially identifies the power dynamic between all of these agents. who is a bit superior to the other one? Are they all equal? Because we know that's not always the case. Depending on the situation of the plant, you might give priority to flotation over comminution to make Lisa and Kim happy, and Lizette happy. So that's key point. So you can decide on that one. And then the validity claim evaluator essentially start identifying, so who says what? So if you, as an operator of grinding, says, my mill doesn't have enough capacity, I'm struggling with the power now. Is it really valid? Do we have any other option? Okay. Or classification says, the pressure is very high, I don't have enough cyclones now, I cannot essentially operate at this cut size. Is it really true? Is there anything that you can do? What about the flotation? Or somebody says, no, we had this regime before, so we have to double the collectors, so it's going to resolve the problem. That validity claim evaluator, it uses the knowledge center and the data and sometimes the help of simulation to identify whether those claims are valid or not. Can we really rely on those ones? The logical assessment agent does some of those logic assessments as well, in terms of how does it fit within the rules that we know from mineral processing? How does it fit within the rules that we know from physics? And then through that process, which is essentially is not as just linear as I explained, it's going to be multiple iteration going forward and backward. There might be missing information that you need to reach out and ask for them. Are they exist or not? Are we sure about that data, or is it like not clear? You might even use some of the simulation or MPCs to predict what would be the behavior if we act like that, what would be the system limits in that space. And then you arrive into a consensus between all of them in terms of what is best for each of these to arrive to the best optimum for the current state of the situation. This is different from APC, because in APC, what you assume is, I know the system, and I know this is the grind size that you have to achieve, this is the throughput that you have to achieve, and this is your target recovery. But when an emergent happens, through this process, you identify that this is genuinely a new system now. What is possible recovery? What is a possible grade? With what grind size and with what throughput? And that's where you essentially rationalize that decision and push it to your system and say, okay, this is now your new target because you're genuinely at the new system now, a new process. And then your learning and evolution agent, what it does, evolution agent, what it does, it captures all of that whole process in terms of all of the negotiation, what was the basis for reaching to that consensus, and put it back into that knowledge center. So then the decision that is made are auditable. You can come back always and say, okay, how did you arrive in this decision? What was the process that you've gone through that and get to that point? And in the future, when you want to get a new cases and you reach out and say, okay, we had the same situation before, you can see actually what was the process you arrived in certain conclusion. Is this new situation genuinely the same as the last one or not? Or what was the outcome of that one? What we learned from that? The ontology engine also is one key point there, because one would say, what about the operational limits, the safety aspects? How do you make sure that the decision that you make is really safe? And that's essentially the site preferences. Any constraints that you have around the safety, any constraints that you have around your operation limits, like water constraints that you might have at certain times, or the amount of dust that you can release or something like that. When you make the decision there, this consensus synthesizer is going to reach out to that ontology engine and evaluate all of those decisions to make sure that you are not breaking physical rules, we are not breaking any of the safety rules or regulatory rules, or any constraint that the site essentially puts into that. And again, that site is specific. You cannot code it into that one because every site, they're going to have their own context. And that is why that AI agent is become process agnostic, operation agnostic. Otherwise, it would be trained to that particular operation. So that is captured there. So this is kind of a general structure. Again, what I'm proposing here is one way of doing it, not necessarily the only way of doing it. To me, my point is rethinking about automation. Instead of trying to design automation for optimization, think about adding a negotiation for decision making as part of that. And my intention is to show that actually from work that we have done, we can show that actually there are pathways that make it possible to do as well. So when I talk about negotiation, there's a backbone there. So I'm using Jürgen Habermas, so I'm a big fan of philosophy, and I'm reading some of these guys. So Jürgen Habermas has a theory of communicative action that is developed for societies around negotiation between groups, which I believe he had a much harder job to do with humans, whereas we use his essentially system, his framework for a system that is much easier. And also Michel Foucault has a macrodynamic of power that actually identifies how the power is distributed all the time. And you can use some of those frameworks for deciding where the powers lie and how they influence decisions as well. So, so that's the kind of backbone of our agents that we are designing. So, and that is what I mean. We are not relying on process. We are process agnostic. The agents that we develop are based on these fundamentals. So they fundamentally train to moderate negotiation, make the decision through that discussion and communication. That's what they do. So some of the points, like in our CPA agent, we call it communicative norm. So like the truth. So is the claim factually valid? Those are some of the inputs that you have. So can we validate your information with our soft sensors? Is there any second point that can be checked to make sure that the data that you say is correct? In terms of the rightness, so does it really, what you say aligns with the goals? Because in my mind, might be the goal is I need to drive the recovery. When I go back to the ontology book, actually, it says the operation decision is not about recovery. We want to make sure that we get metal production. So we can check that. And when they say, oh, we are restricted with power draw now, I'm pretty sure if we put Malcolm there, he's going to basically make the mill run much faster and with more power. He can squeeze extra power from the mill. So that's a question. Is this really a true restriction? And then the uncertainty. Are you really admitting the uncertainty that exists in your data? Or you're completely essentially ignorant of that one? So those are few things that actually exist in that communicative norm in my agent that actually works into that. This is just, I didn't want to bore you with the whole of the details, just to give you a bit of an understanding of what essentially is under the hood there. So the CPA actually is genuinely different from APC and MPCs, okay? So the APC and MPCs, they heavily rely on quality of fixed models that you have there. Even if they are dynamic model, as they call them, they are fixed model because you structure them in a fixed way. They have no ability to adapt to the new systems. You just train them based on those information. They always follow a known trajectory. We call them adaptive, but they have to be adaptive within that trajectory that you define as their pathway. They can go into different parts of that trajectory, but the trajectory itself is fixed. And usually they fail when they're not stable. Again, I'm looking at Malcolm. So we have been in many operations. The moment things start going unstable, the control system, they fail. They cannot do anything. You have to literally go to manual mode, stabilize them, and run them again. And when it go to MPC, they start getting confused, pushing systems everywhere, and then people, they have to shut them down again. So that happens over and over and over. Whereas in CPA, you don't dictate the optimized solution. You first debate that. You agree between all of the parties, what is the optimum solution that is achievable. So instead of forcing the APC system to keep fighting with the bottlenecks because you push one to the high, and then you create a bottleneck, and then you push another one, and then you move the bottleneck, and you do that, we identify actually what is the smoothest pathway for everybody to work at the best that they can without creating a bottleneck. And that essentially forces the system to work optimally as a system, not as an individual unit. One might work underperform, one might work a little bit higher than that, but the idea essentially is not to create bottleneck, it's to create the highest possible achievement in that system by understanding what each system can really do. And the key part also is the human is integral part of that. It's not out of the system to negotiate things outside, and it's not to take it completely out of the equation and say, okay, now I can run easily. Actually, they have to be part of that because we need human to get some of those contexts that is not very easy to learn or capture through the data. That's where the human perspective comes in. With the negotiation that they had in the corridor with the maintenance guy, so they have some knowledge that they can put into that. But still, the process is going to do fact-checking, truthness, and all of those processes to make sure that I'm not just putting some gossip there and then you make decision based on that as well. So that's also key to be there. And the idea essentially is to scale what normally human operators, they do outside the system within the system. Because we know, I mean, I'm talking with many people and they always say we struggle with having experts and people and we cannot have all of those people. So essentially we need some ability in here to be able to scale that. And now essentially we use that perspective. The idea essentially is not to take human out of the equation, but in the face of control automation, what happens is their role fundamentally is going to change, okay? So when you think about operators of today, they keep watching screens and trying to react to alarms and play with the targets. What we want is actually they need to supervise agents, provide the context, and then look at the decisions. When there's ambiguity, they have to have the right to choose what is going to happen. And many of the edge cases, so I don't pretend that the CPA is going to be able to handle all of the edge cases as well. So that's key where the human comes in. When you think about the engineers, they sit in their computers, do lots of data, they are trying to develop models, trying to develop targets, and then pass them down there. For them, essentially, is about moderating the decision logics. Anything that needs to change in the ontology book, anything that needs to amend it in the whole process of decision making. That's what they're going to do that. And also the constraints and the targets of the process. That's where it's going to go into the ontology book to make sure that the CPA makes decision within the frameworks that they want. And then when it goes to the managers, instead of them constantly debating with the manager of the other groups and email and all of that, for them is about what are the bases for the power dynamic? What are the parameters that I want the AI to incorporate in the negotiation between agents? And that's what their role is going to be. But again, we need the human in the equation, not out of the equation. So I think the key point for me is the change in the thinking. We should shift our thinking of digitalization and AI solutions from optimization to discussion and negotiation for decision making. So we need to use them. And I think what we proposed in here was actually, if we want to shift that thinking, there are solution pathways as well. So I've been thinking about this one for almost 3 years. But up to last year, I didn't really have a way to implement it as well. But from last year, we actually came up with that implementation pathway as well. I think that's a key point, a layered approach that actually can leverage even AI as well in terms of moderating that decision-making and negotiation. So the CPA is to automate the key decision-making and scales the expertise of the people, but is not going to remove human out of the equation. Is going to address the shortage of the skills and essentially the amount of complexity of the task that the one human has to go through and change their role to be people that they can observe and supervise and guide the AI moderator in much faster and more consistent way as well. And I think that's some of the key points in my presentation today. I promised actually to make my presentation short enough to be able to have more discussion. So I think I have been posting on LinkedIn about that one as well. So if anybody missed them or interested, I'm happy to keep that discussion because this is something that is not going to be end and finish. It has to be discussed more and more. And I have some references for people that they are interested. If you get bored with your daily life or like me, started getting bored about all of the nonsense that happens in Asia, Southeast Asia, in Middle East, you can start drown yourself in books so you don't face lots of those challenges. Thank you very much.
Was a fantastic talk. Thank you so much, Mohsen. So we open now discussion question already. Very nice.
Thanks, Mohsen. Really, really interesting. I mean, essentially what you're proposing is to take a human committee of experts and replace it with an AI committee of experts. So you don't have to try and wait for 2 months to get into everyone's calendar. And people are not going to be biased or constrained by their own, whatever they had for breakfast, which makes perfect sense. But With any decision by committee, one of the biggest issues that we get is decision paralysis, when there are too many competing objectives and we don't even know what the optimum is. Would an AI committee be, to some degree, also subject to this?
The key point in here, I agree with your point. Essentially, when we have the committee of people that they want to make the decision, if you don't have all of the information that you really need to understand what is the process that you are trying to optimize, then you're not going to know where is the target as well. And to me, the design of this system was genuinely to say, we need a way to capture all of the information that we have, go through a systematic process, and identify what is the boundary of the new system that we are dealing with and what would be the target. So in my opinion, the system is designed in a way that it can identify where is going to be that optimum. Why it can, and the human expert, they cannot do that. There are a few things. One, as you said, the humans are not always factual based on the data and information. They have their personal preferences and beliefs as well. We don't want to ignore those. We want to incorporate them as part of that equation because some of those actually are genuinely valuable because it comes from the expertise, okay? But we want to make sure that it's coming within a framework with the power dynamic and the truthness and rightness check and all of that. But the reason that this system can do that is, first of all, it moderates those human aspects, but also the AI and the system is much more efficient compared to us to process a vast amount of knowledge and the data in a shorter amount of time to get as close as possible to what is the new system. I'm not saying that actually this is going to identify the reality, okay? So I don't know what would be the reality. But what happens is from the data, it can get to the point that is closest to what is the system and then helps you to what would be the target that makes sense. And sometimes it might come up with different objectives as well, so different course of actions as well in terms of, in the face of uncertainty that I have, I think maybe action 1 would be good or action 2, and I don't know. That's where, again, the human becomes into play in terms of, based on the context that I know, I would suggest action 1 or action 2 as well. So that's the key point in there.
Follow-up question, if you don't mind it. You like philosophy, so let's get philosophical. So when a decision is made, be it by a human or an AI agent or a combination thereof, which is what you're proposing, who gets to decide on the quality of that decision? What makes a decision a good decision? And who is a decision maker on the quality?
Yes. So that's essentially, if you think about human, when you decide, you say, okay, this is a good enough decision, and you go with it. Okay? And you always have somebody who's not happy. Mm-hmm. Because each of us go through our own process of deciding what is a good enough decision. So what we're posing in here is not, this is not the good or the best decision that you can make, but you go through a process that is consistent to identify this is probably a good enough decision. So one of the key points in here is actually what we try to do. Again, I don't have all of the answers for this system as well, because we are just, we are developing it right now. So one of the key points is actually we want to incorporate the uncertainty that exists with the data as well. Like many of the work that we do with our soft sensors now in JK, and soon we're going to have a good PhD student actually working on the uncertainty of the data as well, is we can actually capture when a sensor measures 2 megapascal or 100 liter per meter per hour, what actually that number, what's the uncertainty in that number? And what we want to do is we want to incorporate that as part of the decision making. So the decisions are not going to be, this is a good decision, this is the best decision. It could be, this decision has this much uncertainty associated with it. This decision has this much uncertainty associated with it. So in terms of who get to choose it, there are 2 pathways. Either you go through that ontology engine and say, okay, based on these 5 decisions that I have and the uncertainty, based on the preferences of the site, like the safety concerns that they might have, or how much they emphasis on the environment and all of that, the top 2 or top 1 or the best that you can achieve is this one. Or you might leave it then to a human operator to say, okay, between the 2 or 3, based on the context that you know, which one you would choose in the face of risk and uncertainty that you face with it. That's probably the best that we can do at this stage.
Cool. Thanks, Mohsen. Yeah, really interesting talk. And so I've got two comments and then an actual question. First comment is, I think there's an opportunity here to build into the CPA moderator an element that's more explicit on environment. And it's not compliance and governance driven, it's ethical driven. So could we put an AI agent in there that's asking what's the best outcome for the environment rather than what fits the regulation? And so that's one comment. And then the second comment is I guess lots of people are going to be nervous about this. And so I guess it's really important that you begin to consider the communication of this around the role of ethical AI and the absolute centrality of human agency and oversight involved.
So the concern is not about like what you say, it's not about the job, people losing job. It's more about the ethical aspects of the decision that is made.
I think it's both, actually. Okay. Yeah. And then so my final question actually gets to the job one. So, I've already intimated that I think this could be a really good, an interesting thing to explore and do. But on the other hand, the assumption here is that the human in the loop is not effective. So my question is there anyone actually out there doing research on the human in the loop as an alternative to the CPA moderator?
Okay, so in terms of the environmental aspect, I agree with you, but my way of thinking was actually that could be part of that ontological engine because it's context driven. Like if you're operating in Europe versus South America versus Australia, they might have a different mandates and different type of things. I know there is a general way as well, but I think that's my thinking. But yeah, it's nothing essentially against putting it even there as well. That could happen, even the social aspects. In terms of, here we don't want to put human out of the loop. Essentially, that's my way of bringing human in the loop because when I'm looking at what's happening at the moment, if you look at it, in reality, although human is part of that decision-making in automation, but in reality, most of the decision is made out of the loop. So essentially, human is not in the loop at the moment. And my push for CPA is actually, that's an effective way we can actually have human in the loop with the expertise that they can bring to that automation system. And I think most of the reason that they try to push human out of the loop as well, because most of the system thinking thinks that those negotiation and discussion and things that happens there are essentially threatening the stability of the process and integrity of the process. So they want them to be out of the loop and less intervention with the system. Whereas all of what they do is critical. And for us, the CPA is the way to make that to happen. And to me, that's one of the key points in terms of, as you said, the human agency in the decision-making process still is there. And that's why I said I'm not taking human out of the equation because I want it to be in that decision-making process. And in different levels, as I show you in here, they have different way of agency into the decision-making as well. So essentially, every layer, they have their own agency into the decision-making. And those are the people that can control the ethical aspects and all of those points as well. But the key point again is we understand that humans also are not perfect as well. They might make mistakes. They might have biases as well. So as part of that moderation process, we want to also moderate that intervention of human as well. So we don't take away human out of the equation. They still have that interaction, but it's moderated through that power dynamic and the communicative action framework.
Okay. We have one question more from audience, and we have also from the chat. Ma'am? Yes, okay. Sorry.
Thanks, Mohsen. My question is sort of related to the AI is operating like in the real world. So on a real plant, you've often got the situation where you have your power dynamics. So
Yes.
often the decision that is made is not the best decision. It's simply made because it was the preference for the person with the most power. And often that person with the most power is not the most powerful person on paper.
Yes.
Is there a risk that you'll have a similar situation with the AI agents, where one of the AI agents just is unjustly more powerful than the others and gets to make the decisions by default?
Good question. I think I have to think about that scenario in terms of how it might happen. But my way of working around that in terms of understanding the power dynamic in the decision making. So in our macro power dynamic agent there, it's understanding the power dynamic between all of the agents that they're part of that decision making. So now I'm talking about agents, it means the human, for instance, is a shift manager that is part of that decision making, or the grinding operator and the flotation operator. So it depends on the situation. So what we want to do, and also it could be other AI agents that are sitting in another part for making decisions as well. So that's correct. So how you would manage that, I would think that actually, yes, it's a work that we need to do in that macro power dynamic to understand how those power dynamics might shift things. And is there danger in terms of somebody becomes extremely powerful that biases all of the decision? And then that should be able to moderate it properly in that sense. So if you put proper structure into that place. But the whole idea of that micro power dynamic was, first, don't create a completely flat system that everybody has the same power, because that doesn't make sense in reality. But also manage that power dynamic. So you don't give the power, all of the power to one group. But the other thing that could moderate it is that essentially discourse agent as well, because the discourse agent is not only looking at the power, it looks at the facts and the claims that is made. As I said, these are the key points essentially that we look into that. Like these are the three norms actually. We normalize all of the inputs from every agent that we have as well. So there are two filters essentially there. One is observing the power dynamic and making sure that it's the right distribution of the power dynamic, but also the inputs from all of the agents, regardless of their power, is going to go through those norms to make sure that the decision is not only influenced by the power of people, but also by the input.
Here are two questions from the online. The first one is from the Hacking Diamond. Are there examples of similar CPA systems being used in other sectors already? And the second question is how to identify if the CPA is giving wrong or biased recommendations, or in other words, how often will you need recalibration or training?
Cool. I think the first one, no, because this is a concept that we developed in here. So they are not operations at the moment. I mean, we are working with one group at the moment to essentially, because we are building a proof of concept at the moment, and we are working with a group that actually they have customers in oil and gas that we want to essentially check the proof of concept of this idea in a complex situation. Obviously, before that, we're going to do it in lots of simulation environments. So we're not going to be crazy enough to go and do it in a real operation. So we do lots of simulation, and then there. It's not happened yet, no. In terms of bias, one thing is, the model actually, it doesn't need recalibration as such. It's more about you might update and improve these agents based on the experience that you get in terms of how they perform in different situations. We might actually add new agents into that to improve their work or update some of those agents as well. But they are not linked to any process. Therefore, they don't need really calibration to the process as such. It's more about their ability in terms of what do they do and how they perform it. So if I'm using it in one case and then another case and I see some differences, I might arrive in terms of, okay, I need actually to retrain my evaluation agent to make it with certain other aspects. That might happen. In terms of the bias, it's a tricky part. For us, it's more about design of the decision making in a way that inherently cannot be driven toward a certain bias. But again, the knowledge center is one of the source for us in terms of what are the realities on the ground and what has been seen in the process in the past, that when you're making a decision, you can compare it against them. And because those decisions are auditable, So if you start seeing a certain decision has been made very frequently unjustified, you might be able to identify some of those as well. Whereas in the current form, because all of those negotiation and decision operators happens outside the system, is not captured very well. So you're not really able to identify any of those ones. But this one actually has that process built in, so you can actually identify if there is biases.
Okay, thank you, Mohsen. Here is a comment from online. Not a question, but a comment. MSHC human factors team have done a lot of work in the human systems integration space in regard to the autonomous equipment implementation. Please come and talk to us if you are interested in this aspect of technology implementation. It is from the Daniel.
Yes, definitely. I mean, I'm aware of, we have the health and safety group in here that actually they have done lots of work in space as well. And I'm aware of them, yep.
Okay.
I think there's one more question there, Adam. Oh, there are many questions. Are we out of time? Adam.
Hi, Adam from Hitachi. Everything that the system's actually working on in a plant is the learning opportunities where we train up. You know, they're the conversations where we train up engineers, technicians, and everything else in how the plant runs and how the decisions are made over a period of time, as well as other skills like negotiation, you know, being able to run evaluations. A system like this, how would we maintain the other skills around the operation? Would not over a period of time we slowly lose our ability for the people to optimize what's going on and know if it's a good output or not?
Very good point. In fact, in here, I'm not taking away the human ability to negotiate and discuss. What we try to do in here is actually, instead of those negotiation and decisions being outside the system and then dictate to the system, we want to bring them in. So in a sense, what happens is the human expert that is there through the interface, it will still negotiate the things that they want, the objectives that they have, and the limitation that they face, and even with the other essentially human through the other systems as well. What this system does is actually first capture all of those negotiations as part of the system, but also channels them through a structured framework. Like things like power dynamic or personal biases then can be toned down and incorporated. Essentially, then those inputs could be incorporated as part of the decision. So essentially, we don't take away that ability. And still, I think the human is going to need to learn those and get more experience as they interact. But what happens is I think the process of decision-making has a way now to capture those negotiation and points as well. So the objective is not essentially saying, okay, you guys are not needed anymore for making negotiation. Actually, I want them, but now it's going to be channeled through that process to be part of that system.
It's okay to take two more questions?
I'm here.
Okay, the last two, based on the time. So please, Lisa.
It's not really a question, more of a comment. I think you've got a great map for the structure of the decision making, but you're going to need a similar map that would outline where does the accountability for each step of the decision making lie and who bears the final accountability for the consequence of each decision.
Yes. And again, the reason at the moment our strategy essentially was human is in the loop and the human is accountable.
So a single human is now accountable for everything.
Whoever approves the decision, yes.
That's a very heavy burden.
But at the moment, human makes that decision as well, like in operations. But
so essentially, you're centralizing a lot of power in the hands of one human.
No, again, remember, this is what happens is, like when you go to site now, what happens is there's lots of negotiation. At the end, somebody makes a decision and they go. And that person is accountable. This is going to happen the same way.
Okay, with not enough time, I have a lot to say, but there's not enough time.
Yes. I mean, again, I don't have all the answers at the moment, but the key point for me is I wanted to point out the fundamental shift that we can make in our way. I'm not saying this is the only way of doing it. What I'm saying is there are ways that we can, instead of going to optimization route only, let's think about negotiation part. Sorry.
Hey, Mohsen. Kind of to Lisa's point as well, is any of these agents actually the executive agent that produces the decision, or is it just a combination of the discourse?
So the idea essentially is you have a moderator at the top that actually interacts between the agents to essentially coordinate the activities between different agents, who has to do what and all of that point. So essentially, this is a council of experts that was pointed out, and you have a moderator at the center that actually moderates the interaction. But at the end, it synthesizes the decision and bring it down to make an approval for making the decision.
Yeah. And would it be feasible to turn this into a statistical exercise where you would have thousands of these agents run the same decision instantaneously and then
come up with
see the variability of And then the last point was probably back to his, that it to a point seems like you may maintain some of the expertise of the people who are overlooking the agents, but it's almost like having two people have two AI agents have a chess match and they're all cheering for their AI and going, yes, that was a great move, but they've got no idea what's going on. And over time, they'll, not have that expertise to be able to determine what was the effective decision or why it was made.
I'm not sure if I'm following your last comment though, but to me, the key point is that process essentially is designed in a way that actually you always follow a proper framework for decision making. It's not designed to influence the decision, what decision is made as well. It's a process that actually helps to bring that negotiation aspect in a structured form to make the decision, but based on the facts and the information that you have and the uncertainties that you have and the missing information that you have as well, which is always the human expert makes those decisions, but it's not captured in the system. And at the end, they hit the go and they do that. But we never know what was the basis for that decision, what was the whole context. And we never know actually, did you guys knew about this fact? Did you knew about that information as well? We never know that. But that's what's happening in there. And the human expert at the end needs to be in the loop because they understand the context. They understand the situation. And when it comes to age situation that you don't know which decision is really the right one to go, because some of them might be obvious and you can hit the go. That's where the human, again, brings that understanding of the context to make that final decision. And obviously in those critical points, then they become essentially accountable because they have to, because what we do is we provide them with the better information for make decision, but we don't change the way that they need to make the decision.
Okay.
Cool.
We ask you all to thank Mohsen for his presentation today. Thank you. Next week, we will have Doreen Gomez from the University of Concepcion talking about the block caving modeling, the cheating experience. Hope to see you all here. Thank you.